So our topic today, as I said, is collaborative learning in a multiplayer setting, all designed for experimental psychologists. And with us, we've got Matthew Johnston and Kelly Wolfe, who are both based in Edinburgh, at the University of Edinburgh for Matthew, and Harriet Watt for Kelly. And just for those of you who are with us today and who haven't heard much about Gorilla yet, I'm going to give a quick overview about what Gorilla is, what we do as a company, and then we will hand over to Matthew and Kelly for their presentation. So what's inside Gorilla? Gorilla is this all-in-one, powerful, easy-to-use platform that allows researchers to create surveys. It has feature parity with a tool like Qualtrics. It's got a task-building tool, which offers feature parity and more functionality compared to, for example, ePrime. And then you can link those elements together in an experiment flow so that you can go from surveys to tasks into, for example, a randomizer node, which randomizes you to different conditions, onto further tasks, which can be presented in a counterbalanced order. And then we have these advanced tools like a game builder, a multiplayer tool, which is the focus of today's session. We also have a shop builder, and we allow UX and UI simulations. Let's have a quick look at what Gorilla looks like. All this is very theoretical, what I've just mentioned, but let me show you what this actually includes. So we support traditional reaction time tasks. We could have any type of stimulus in any response. You get accuracy reaction time measures as well as trial by trial randomization. We also have a survey tool. Here at the moment, you're seeing the spreadsheet and how you can set up your different stimuli so that you don't have to recreate all those different trials. And you can then randomize those within the spreadsheet. You get to choose from a range of different components. And here you can see our questionnaire builder tool, which I already mentioned. This does all the complicated things like matrix survey questions. We can support scoring and branching and subscales as well. You can see here is just a slider where you can move the slider around. Those are different types of questionnaire items you can use, and then here the scoring. For the experiment builder, this is where you put everything together, your tasks, your questionnaires, and you can also implement some randomization and counterbalancing. We see some incredibly sophisticated experiments. I think we've seen experiment trees that had over 80 components, 80 nodes in it, so quite a big experiment flow. We also have advanced functionality like eye tracking, mouse tracking, audio stimuli. You can use microphone recordings, webcam recordings, drawing tasks, and a lot more. So hopefully that gives you an idea of the new possibilities we have in online behavioral research that go far beyond surveys. Our session today focuses on multiplayer, and I will hand straight over to Kelly or Matthew, whoever is first, to start their presentation.
That's great. Thank you. Hi, everyone. Thank you for coming for today. So I'm going to share my screen, so hopefully you get to kind of see my slides. To the people that are on the panel with me, please let me know if and when they show up. Hope it looks okay. Can you see it all right? Perfect.
Yes, we can.
Okay, so today we're going to talk about collaborative learning, and specifically about the task we were developing and designing to test this in older people. So me and Matthew is also here. We are working on it together. So just to kind of give an introduction to who we are. So today we have Matthew Johnston, who's here. He's a postdoc at the University of Edinburgh, and I'm an assistant professor at Harriet Watt. Actually, me and Matthew got to know each other when I was a postdoc at Edinburgh, so that's actually how we met. And we're still working together, even though we're at different places. And then also, who's not here today, we're working with Sarah McPherson as well, so she's part of the project with us. But we are giving her a delightful break from presenting for once, so she's not here, but you'll get me and Matthew today. So what we'll talk about today is I'll give you a bit of background on the topic first. So why are we using this task? What are we designing it for? Then Matthew will give you an insight into the task design itself. We'll talk a bit about the study that we're wanting to use this task for. And then afterwards, if you have any questions for us, please feel free to let us know and we'll do our best to answer any questions you have. Okay, so I'll start first. So why we're doing this is actually because we are looking at older adults and learning in older age. And so with aging comes some great benefits. We are generally more positive as we get older. We've gained a lot more wisdom over our life, and we tend to place a higher value on our relationships and friendships. But we also know that as we age, there are some negatives. So we have experienced declines in things that are, say, the ability to process new information. So how quick we are and how much we can do this. We also may struggle a bit more to remember certain things. So it's easier to forget your friend's phone number or certain other details that you value. And actually, those kind of abilities really affect how we learn new things. So basically, as we get older, learning new things or new skills become harder. And ability to learn in its simplest form requires three separate components where we talk about encoding, maintaining, and retrieving knowledge. And so encoding is the first stage where basically you see something, so you're perceiving the information, you're getting it into your system, and you're trying to process it in a way that it makes sense in your mind. Maintaining is the part where we're storing this information to hopefully use at a later time. And then retrieving knowledge is taking that information from your mind and applying it and remembering this information that you've had stored. Um, so what we have learned so far in other research is that older age is associated with difficulties in obtaining, so encoding this, but also maintaining this information, both in short and long term. So if, say, for example, you are trying to remember a phone number for a short period of time, for an older person, that'll be harder to do, but it also will be harder for them to remember this long term compared to a younger person. So these kind of declines affect people's lives day to day. So for example, we still require learning even as we get older. There's always something new to learn, and there's lots of things that we need to remember. So older people struggling to remember things or to learn new things affects how much they can live their lives independently. And that's actually one of the things we're trying to look at. So one of the ways you can kind of combat this, so the difficulty in learning as we get older, is by doing it together. So that's what we call collaborative learning, where we work and communicate with another person to learn a new task or a skill instead of learning it by yourself. So you could learn with a friend or a spouse or anyone. So if you think about how we have learned throughout our lives, like in school, we are often in classrooms, right? We work in groups, we have group assignments. And so even as we're working, we're still doing learning, and often we do it as part of a team. So collaborative learning is not entirely experimental. It's something we do day to day anyway. But now this is something we're specifically trying to use to help older people learn better. And so this area has not been hugely studied, but actually we're kind of experiencing a new wave of research. So in the last 10 years or so, more and more researchers have looked into this in a variety of different ways. And I'll kind of talk you through a little bit of what that looks like. So the reason why collaborative learning could be good is because learning with another person makes it also something social. And so where we may have struggled when we age to learn something new by ourselves, maybe when we're doing it with another person, the socialness of working with someone else might help us. So we may not, for instance, we might not just remember it as new knowledge we've learned, but we also might remember it as something we did with this other person. And so for older people, the social aspect of their memory is a lot better protected, and so that could maybe kind of cushion the blow of that decline they would have by themselves. So learning with someone together and making it social could actually help older people remember that information better. And then working together can also offer people additional other support. So say, for example, if me and Matthew will think about this presentation 5 years from now, and I'm trying to remember exactly what we were talking about, Matthew might go, oh yeah, I was there. I did this part about the task that I was talking about, and that might help me remember what I was saying today to you. And so working with another person doesn't just have the socialness that might help, but the other person could also kind of prompt you to remember things you otherwise would forget. Now, just to give a quick overview of what's been done so far, there are studies on collaborative learning. Me and Matthew aren't the first people to do this, but the existing work really differs. So there's lots that people have looked at in different directions on this topic. So one of the ways that they differ is actually the type of partner. So some studies will have just had married couples in. Some people have specifically looked at strangers. So you're matched up with someone you've never met. Others allow, people to bring in siblings or friends. And actually, there are studies that have used a robot as a study partner. I will show you a picture of that later. And another way people have differed is the size of group. So the majority of these studies are actually done where two people are matched up, but some of them have also had large groups. So say maybe 10 people learning together at the same time. Online or in person, very relevant today. So we're looking at a task about this later. There are some studies that have looked at whether some of the things could have been done online or in person. So computers have been used, things on paper, but also different locations. And then there's study design. So have collaborative learning studies been done in a lab, so like an experiment. Some of them are in community centers where you can find lots of older people and have room for them to learn together. And some of them are just done at home as well. And then also what they differ is whether people have included a measurement of how well older people learn if they're on their own. So for example, if we wanted to know how well older people learn together, we probably want to see the benefit by looking and seeing how these people will have done it if they did it by themselves. So having that extra kind of condition to see how they did at the baseline versus how they did with another person is also really helpful. Not all the studies have done that, and some of them differ in this. And then lastly, they have also different in types of tasks they've used. And I'll talk a bit more about that in the next slide. So there are several types of collaborative learning tasks that already exist, and they're quite different. So one of the ones, for example, is a mock GPS system, where in that study, people created travel routes with another partner. So they had to fulfill certain criteria and get a route set up. Then we have another one called the map task, which is similar, but instead it's on a piece of paper with landmarks, and you have to plan a similar route out, but more like a map versus kind of on the GPS. There's also IT courses to help older people learn computer skills. So they would sit in a room and do the course that's pre-made, and then by the end of it to see how much they've learned over time from that IT course. Things like a medication scheduler. So learning how to use this, how well acquainted do people get over time learning this thing, and do they do better when they did it alone versus with a team member or a partner. Then the favorite kind of game, the bingo game, where instead of it being straight bingo, it actually teaches you little bits of information about your health and nutrition. So it's not just a game, but it's combined with, by the end of it, the researchers would hope that older people would have learned a bit more about how to maintain their health and nutrition better. And then the last one is the referential task, also called the barrier task. And that's actually the one we're going to talk about for the rest of the session. So this task, the barrier task, is actually one of the most used collaborative learning tasks, and it is from about 1986. There are a few other versions, but that's actually the version that's most used. And in this task, people are doing it together. So there's only two people, and they're given two roles in this, called the director and the matcher. And the participants have to communicate to each other to basically put the figures you can see here on the right that kind of look ambivalent. Some of them may, look a bit more recognizable than others. And the participants have to talk to each other to figure out what picture goes in what spot. So the director, for example, literally directs by giving the descriptions, and the matcher will take those descriptions and ask questions to try and figure out what picture goes where. So in theory, it sounds quite simple. And in reality, once you're sitting there, we have practiced this together as well, it can be quite complicated based on the picture that you're talking about. So participants do this over 9 trials, and each time they use the same 12 pictures. And the reason we're doing this, so we're doing 9 times the same pictures every time, is actually because we want to see how well people learn. If we gave them different pictures each time, we probably wouldn't see the progression. So we might want to see how many of them we get correct on the first trial, and then how that changes as they go on. So by maybe trial 5, they may have done better than they did in the beginning. If we change pictures each trial, we may not be able to see that as much. So that's why they're the same images every time. And like I said before, they're typically done with pairs of people. So someone they bring in or someone that they're paired with that they've never met. So in the instructions, people are literally told to play this game. One person of you is the director and the other one is the matcher. The director will describe the figures to the matcher from spot 1 to number 12. You have to work in order. Based on the director's descriptions, the matcher places the cards on the grid. The main rule is that you cannot look at each other's cards. Because of this rule, people have a short barrier between them. And other than that rule, anything goes. So be creative. You can communicate any way that you want to. You can use gestures, facial expressions. You can talk as much as you like. In some of the studies, people will have actually sung to each other what the instructions were. People try and do as quick as possible. So they have a lot of variety in what they can do. At the end of the trial, the person who's a researcher will let you know how many out of 12 pictures you placed correctly, but they will not tell you which. So if they've made mistakes, they have to figure it out themselves what those mistakes are. And then lastly, you will complete the matching game 9 times. Each time you will use the same cards, but they'll be placed in a different order on the director's grid at the start of each game, because the director already knows where the pictures are supposed to go. So just to kind of show you what that looks like, I actually have a video from 2 people playing it last year.
Number 5 is the one that should be a dog with the tail to the left and separate from the square face. Yes. Number 6 looks like a pot plant.
Yeah. Square base.
With a square base.
Okay.
So that's kind of what the trials look like, where the person on the right is the director. They have pre-made grids, so they know where what is supposed to go. And then the other person, the matcher, has loose cards, and based on the descriptions, will kind of communicate and try and figure out what picture goes where. So here's a couple of examples of sessions that have been done so far. So on the left, for example, we have a session where this has been used with a Confederate. So we had a student take part, a research assistant, who is doing a slightly different role than what the researcher or the participant thinks that they're doing. So here, actually, the person was giving them instructions based on an existing kind of script. In the middle, we have the task of the robot. So we actually had a programmed robot give responses as well, interact with the participant. And then on the very right, you've seen them already. We have the familiar couple who came in together and are doing it and match a director with each other. So one of the things that, it's a great task and we've used it quite a bit. That being said, like any task, there are barriers. So the barrier task also has some, issues that we found using over time. And one of them is that this kind of task that we're doing generates a lot of different data. So you will have seen that we have a video recording. We video record every session because the conversations between people give us information that we're interested in. But that means that we have to then transcribe all these videos and the sound. It also gives us information about what places or what cards are placed where. And so there's lots of things you have to pull together and analyze. And that also means that the processing of this data is quite lengthy. So it's not usual. This takes months to do. It also relies quite heavily on being in person. So every example you've seen here, people have had to come to the department to do this study. And that also means that people who are unable, for whatever reason, to come and do the study in person are unable to take part altogether. So those people are excluded, even though that, we and they don't intend to be. And then also it can be really difficult to replicate because this is all in person and it's an older task. it means that there are lots of studies that have done a similar approach but slightly different. So it means that you have to really keep track of who has done what to be able to replicate it again. So it's quite hard to make sure to log that properly. And so what that means is that there are various versions online of this task. So everyone has done slightly different. Documentation can be hard to find. So what were the instructions? What if this or that happened? It also means that because of all this data that you're collecting, you're taking longer processing it and therefore publishing the data. And then lastly, because the fact that it's in person means it's hard to reach people that are rural or populations that are non-Western, educated, rich, and so on. So you're quite relying on a small sample of people that are able to do this. And so our idea here, a solution to this could be making an accessible and an adaptable online barrier task that includes some time-saving features, so researchers don't then have to spend half a year working through all this data. And that's actually where I'm going to hand it off to Matthew.
Okay, great. Thanks, Kelly. So I'll just share my slides so we can. Hey, great. Can everyone see my slides? Okay, great. Thanks very much, Kelly. So yeah, I'm going to talk about how we actually move this barrier task, which has been used a lot in the literature, to an online version using the Gorilla platform. But first of all, I'll talk about what variables we're actually wanting to capture in the barrier task. And that's an important thing to actually think about when you're designing your tasks, both multiplayer and just single player games. So in the barrier task, we measure the correct number of tangrams that participants get right in a given trial. So they can get a score out of 12 every trial. We also measure the time it takes participants to complete a given grid. And as you can imagine, coding this manually actually takes a long time, from looking at videos and trying to timestamp the start and end of the trial. We also measure the number of words that participants actually say during a trial. So as participants progress through the task over the 9 trials, they should actually get better at matching the tangrams into the correct spaces. So over time, they should use fewer words and talk to each other in a sort of new language almost that they create throughout the task. And also we measure the number of conversational turns, and this refers to the amount of talking between participants. So you imagine participant A saying something, and then participant B replies, and then participant A replies again. That's 3 conversational turns in that trial, so a back and forth between 3. And as Kelly mentioned, we manually code this from videos, and this is incredibly expensive and takes a lot of time, and is actually prone to human error as well. So having an online version will actually automate a lot of these processes for us and really help us focus on writing up the task rather than just spending time pre-processing data. So I'll show you first of all our Gorilla multiplayer version of the task so far. So we're capitalizing on Gorilla's multiplayer component here. And this allows 2 players to complete the game concurrently from across the world. So they're both collaborating on the task in real time. So half of the participants are given the director's screen. So they're given the director's role. This is the screen that they see. So imagine I'm playing the game with Kelly here. I see Kelly on the other side. She's being the matcher. And I see all 12 items here in the correct position. And then I have to describe to Kelly what each of the shapes look like. And Kelly over here is matching the instructions that I'm giving. And she sees 12 shapes at the bottom of the screen, and there's an empty grid there, and she has to move each of the shapes into position. So I'll just show you really quickly what this looks like. And just to note as well, in our task, participants stay in their roles throughout the entire experiment. But if you're designing this task, you can flexibly alter their roles throughout the task. So one participant doesn't have to stay as the director, for example. You can switch that up. You can be quite flexible in the Gorilla design. So this is what an example of our task looks like. So I'm just showing you the matchers screen, and I'm showing you what they actually do. So the director gives an instruction, The matcher asks a question about that instruction. The director confirms their response. And the matcher thinks they know which one they're clicking on, so they're dragging the shape across. Okay, and now they work on the next image. So the director gives another instruction. The matcher isn't quite clear what that instruction is. They ask a question. The director responds. And then the matcher thinks they know what's correct, and they move on to the next shape. And they go through each of the 12 items until they complete the grid. And then at the end of every round, we show them a score out of 12 for how many they got correct. So that's the task in a nutshell. I'll just go a little bit in more depth about how we actually created this task and go behind the scenes. So before the task even begins, participants are randomly assigned to one of 6 sets that we've created. And we can switch through the sets here in the spreadsheets aspect of Gorilla here. So this is set 1, in which we've got 12 different shapes. Now, Kelly has created these 6 different sets from piloting to ensure that they all have this equal number of difficulty and they're controlled for a different time type. And then participants are either assigned to the director or the matcher role, and this can be done in the spreadsheet aspect of Gorilla. So player A is given the role number 1, and player B is given role number 2. So number 1 refers to the director, and the second participant will be the matcher. And as I said, that stays fixed throughout the experiment, but of course you can change that. So you could change it so that you flip it over for trial 2 and switch roles quite easily for participants. You could even introduce this randomization component, which randomizes it throughout the task. And importantly, we use multiplayer components that Gorilla has throughout the task. And this allows participants to receive different instructions, for example, any object that can be used in Gorilla. You just add a multiplayer component to it, and you can toggle which participant sees that object. So once participants have been assigned their roles, the task actually starts with a set of instructions. And participants are given different instructions depending on their roles. So for example, the matcher might see a set of instructions that tells them they need to listen to the director, while the director gets instructions that they need to give instructions to the other person. And using the multiplayer component, for example, we might just have a text box object, for example, and we can say whether that text object is shown to the player A or player B using the multiplayer component. And once participants have received their instructions, we then ask participants to meet each other because this is a collaborative task. We want them to work together. So we have a little section for them to familiarize each other. So to do this, we use the video chat component that Gorilla has for multiplayer. So this component allows players to see other players that are working in the game. And Gorilla allows you to record both the video of what's being shown, but also you can record the audio during the video, or you can record the entire screen, which is actually what we're doing in our task. So you can see the click movements that the participant does, and you can see the video chat component. You can also toggle whether players see themselves or see the other participant. So for our task, we only want participants to see the other person, but you might have a task, for example, where they want to see both themselves and the other person. So once participants have been introduced to each other, they begin the 9 trials in our task, and this is initialized from the spreadsheet section. As you can see, we have 9 different rows pertaining to each of the trials here. Importantly, I should say as well, the positions of the objects in the trials, I'll talk a bit more about this in detail, but on this stage, you can randomize where things are positioned on your screen. And that's what we have done in our task. So we've used the randomizer aspect of Gorilla to randomly create new grid configurations for each participant. That is much, much harder to do in person, because if you think about it, we have to physically make each of those grid configurations, and we can't make every possible combination that could exist. Whereas using a computer, we can randomize that and use every possible configuration. Okay, so going on to the actual trials, I'll start with the most complicated part, which is the trial screen. So this is completely different, as I've said, for the director and the matcher. So the director sees a complete grid at the start, whereas a matcher sees an empty grid and 12 movable objects on their screen. And as I mentioned before, the position of each of those objects are initialized by the spreadsheets. So the correct positions that the director sees are randomly shuffled every trial, but we also shuffled the position of these objects down here. So that just means that these positions, participant can't use any heuristics from these positions to get to the correct answer. So it's completely randomized. Each of the objects are also draggable. So we're using Gorilla's draggable component here, which I believe is a relatively new aspect of Gorilla. And it allows you to drag objects across the screen and put them into different spaces. So one by one, as I said, the matchers have to follow the director's instructions for each shape. And they move each of these shapes into different spaces. So each space stores what is currently there. So it uses the store occupant, and you can put a network field into that. And this allows us to see what shape is in a position at any point during the trial. And this is recorded every time a click occurs, allowing us to observe the trajectory of learning throughout the task. Whereas previously in the in-person version, we typically just recorded how many they got correct by the end of the trial, because that was the easiest thing to do. Whereas here we can actually see participants' trajectory of learning, because in this task, participants quite often change their mind. They put a shape into space 1, and then later on they come to shape 4 and they realize, oh, actually, I think this is maybe fits more with what the director said earlier. So they can change their mind, and we can now, using Gorilla, actually see the exact trajectory of learning throughout the task. But most importantly, we do also record the final position of the tangrams, and we keep that for calculating later on. Importantly, I also want to say we can also count things like how many clicks the participant does and how many times they drag and drop an item into each of those spaces. So what we're using here is a tag. The tag is called drop. So every time an image goes into a space, that drop is given. And we add a score of 1 to our network field counter every time a drag occurs. And that just lets us then add up how many clicks happens during the actual trial. And also allows us to say that when it hits number 12, when each of the spaces are filled in otherwise, the continue button then appears for the matcher, allowing the pair to progress to the next trial. So that's quite important that we've built that in, because it means participants can't just skip the trial at the start. They have to actually complete the grid first of all, and then that button appears for them. So I'll just show a little example of this happening. So I've disabled the video here for this testing purposes. I'll skip to the end so you don't see all of them. And then you see that the click here button appears. Okay, so going on to more behind the scenes then, this is a checking score aspect of the task. So participants don't actually see this screen. This is just presented for 500 milliseconds, a blank screen for participants. But behind the scenes, we're scoring the matcher's final grid compared to the director's initial grid. And for each space, we evaluate what item or what tangram is in that space and whether or not it's equal to the position values that are initialized by the spreadsheet at the start of the experiment. So we give a point for every correct position that the network field finds, and then we add that to a new network field that we call check score. And this is done for all 12 spaces, giving us a total score out of 12. Just to note, you might notice it says 0.5 here. That's because for every event that happens, it adds 0.5, so the start of the trial and at the end of the trial. Moving on then, what do participants actually see after they give a trial? So we tell participants their score and what it was out of 12. Participants are shown the round number. They are also shown the network field check score here. And importantly, participants can see their collaborator at this point. So they can chat to their opposite member and see, okay, what did we get right? What did we get wrong? This is what we need to do next time. But as I said, this is just our task. You can be completely flexible in your task. You might actually want to hide what the participant sees here. You might not want to let the other participant see their opponent if it's not a collaborative game. You can do all sorts of things here. And participants repeat this cycle for 9 trials. And then finally, in the end screen, they're thanked for their time. And if they're taking part in Prolific, you can actually have a section for them to enter their Prolific ID. It's important to record that detail. And then what does the output actually look like? So what does our data actually look like? So we get a CSV file, and this shows us the number of correct answers per trial. It shows us the length of time per trial, and importantly, the length of time for moving each shape. So we get a row created for every event of the trial, allowing us to see the position of the diagrams moment to moment. And also we get separate video recordings for each participant and each trial as well. So that actually saves a lot of pre-processing for us. So going back to our dependent variables, before we had to manually code these and it took lots of time and money. Whereas now with this online Gorilla task, it automatically codes the correct answers and time taken, and also gives us further insight into learning during the trial. We've also got videos, and these videos capture how many words are being said in a given trial. And we're planning to use AI tools to actually generate scripts of the participant's speech. And this will allow us to more quickly code these variables. And also it could be used to having a bit more rich data that we might investigate with qualitative analyses. So we can explore things like strategy use, whereas some collaborators who are more successful might have used certain strategies that are more beneficial for learning than other pairs of participants. Okay, so that's our task. I'll just quickly go through our study design and how we're actually going to validate this task. So our plan is first to validate this task and also compare it to results that we've collected in person. And we also are very interested in whether older participants can use the task. And additionally, we're going to explore whether we can get AI tools to code variables from those videos and generating scripts for us. So our study design is between subjects, and we're exploring pairs of older versus younger adults. All of them will be unfamiliar to each other, and participants will be recruited via Prolific. So this is our rough recruitment strategy for now. First of all, we aim to post the task on Prolific, where participants can read about the task, and then they sign up completing a Qualtrics form, and embedded within that form is a Calendly or You Can Book Me page. You can use various other sites to do this. And that allows participants to choose a date and time that suits them to take part in the task. Then when pairs of participants are matched by picking the same date and time, we send them a confirmation email automatically alongside questionnaires. And then these tools can automatically send reminders 24 hours before task, 1 hour before task, and 10 minutes before the session if you want. And then hopefully both participants will join the session at the same time. And because of the videos that we record, we can quite easily inspect data quality afterwards to ensure that participants completed the game the entire way through and they played properly. So using these online tools are by no means perfect, but they can actually streamline a lot of our recruitment processes as well as pre-processing data for us. So overall, the benefits of testing online and running multiplayer tasks online is it automates a lot of the work for us. It might be a bit more effort at the beginning, but over time it pays off. Researchers can save time and money in terms of creating task materials and in terms of being present at the testing sessions or in terms of pre-processing data. It also, using platforms like Prolific and Gorilla, it allows us to reach more diverse populations, as Kelly mentioned, which is really important. And if anyone here is interested in doing some cross-cultural work with Kelly and I, please feel free to reach out to us. It'd be really interesting to see how this task works in different populations. This is particularly important for hard to reach populations or populations that maybe struggle to travel into the lab, like older participants, for example. Having this online platform allows them to take part from the comfort of their own home. It allows us to really easily monitor data quality as well, which is something that doesn't always happen in person. And because we have these videos, we can see exactly what goes on during the task and we can moderate the data. It also leads to more reproducible science and allows other researchers to implement similar strategies to us to try and replicate the findings, but also it allows other researchers to be quite flexible. They can now take our task on Gorilla, which we aim to make public once we've validated the task. The participants or other researchers can use that task, alter little bits of it, and then run it again with variations. So that is everything from me. So thank you very much for your time. If you're interested in finding out more about our task, I have a little QR code here. And yeah, that's me. So I'll pass it back to Joanna. Thank you.
Thank you so much, Kelly and Matthew. That was a fascinating talk, and we had some really good questions as well. So thank you for taking the time for speaking here for us today, and I wish you best of luck with your research. We're all very interested in hearing about the results once you've got them. And yeah, to the audience, I hope this was interesting to you as well. And we do have a little feedback survey at the end of the webinar, which will just open up in your browser. Feel free to fill that out if you've got anything to say or any new topics you would like to hear about for any future webinars as well. Do let us know. We're always happy to innovate and to invite new people to speak about research for us. I hope you all have a good evening or afternoon wherever you are in the world, and yes, we will have a next Gorilla Presents which you can sign up. It's about linguistics and AI voice perceptions and human voice perceptions. So yes, just saw someone saying happy Halloween to everyone in the chat. You were a great audience, loads of questions. I hope you have a good rest of your day. Thank you, Kelly and Matthew.
Thanks.
Thank you. Bye. Happy Halloween, everyone.